Hello everyone, my name is Avosa and I will be giving a short presentation on the research that I've gathered for a small spatial structure based on my designated typology, which is the tensile structure. Then I will briefly discuss my design outcomes from modeling in Grasshopper and the analysis and evaluation generated by Karamba. Tensile structures provide a wide range of options for conceptual design and exploration. The way in which tensile stress is applied to a shell membrane, for instance, will determine how the structure is erected, and depending on how rigid the joints and fixings are, it will be able to support itself. I had the opportunity of finding this out by modeling in Grasshopper, whereby using kangaroo physics to produce simple iterative models of tensile structures. The use of masts and cables, as well as the extremely versatile and optimized shell membrane, were implemented and realized, respectively. I distilled my research down to the core principles used when working with tensile structures in order to design a simple yet functional spatial structure. This would give me a good understanding about how tensile structures work in general. Therefore, I concluded, after a good number of hours doing form finding and experimentation, that a long-standing column at the centroid of the structural envelope would be suitable in demonstrating the effectiveness of having a shell membrane wrapped around it. Included in the small spatial structure design are 6 shorter columns surrounding the inner column. They are slightly bent outwards and are formed by placing them on the corners of a reference 6-sided polygon. The shell membrane would eventually be placed over the structural elements and fully fixed to the ground and top of the main central column. The use of a double shell membrane structure was suitable since one membrane would be wrapped around the lower half of the structure. The use of steel cables will allow the smaller columns to be connected together from the edges to the top faces, whilst allowing the shape of the shell membrane to be reinforced under tension. And now I will share screenshots of my findings based on the Karamba structural analysis.